Okay, so guys, before he gets to start, welcome again to our Cairo class. I mean, today is the fourth week, and it's been a very good journey with all of you. And yeah, I just hope everyone gets to meet um up with the last day, which is week 7. Right. Normally we're meant to have the StarkNet team join us today, but then they told me that they will be busy for today, but then either next week or upper week they'll get to join us. Okay, so I know I said in the group that they will join, but then they couldn't meet up, so apologies for that. So Gospel, over to you to handle this.
All right. So welcome again, everybody. Like I said, the staff wasn't meant to take today, but they were in chance, so I would take today's class. So today we'll be talking about, we'll be going a bit in depth about how Cairo works, and also I'll be explaining how to write tests in Cairo. So yeah, let's go. So let me walk through. So this, can you see my screen?
Yeah.
All right, cool. So yeah, today we'll be talking about memory models and registers. We're talking about revoked references. We'll be talking about recursions, and we'll be talking about writing tests in Cairo using Protostar. So okay, let me just add that here, using Protostar. But yeah, so these topics are quite interesting, and because they are, you might have seen some of them in the documentation, but I bet you it's hard to understand. So I'll do my best to explain them in a way that I believe will make sense and will be more simplified than what's on documentation. And I'll reference documentation from time to time just to make some things make sense. So yeah, let's go ahead. So memory models, right? So the first one, memory model and registers. So from the documentation, the most prominent thing about the Cairo memory is that in Cairo, you only write to the memory. You write once to the memory, you can't change. So I said here, Cairo only supports write once memory. That is, once a value is set, it cannot be changed in light of a set of instructions. So what does that mean? So imagine that you were trying to run a loop, right? You're trying to run a loop and you set a value, right? In that same function, you can't change the value of that particular variable you've set. So and also I'll be using this part to do some explanations, because this class will be a bit theoretical, because some of these things, it's not easy to replicate them, especially when you don't have something like Remix for Cairo. They have something like that for Cairo, but in Remix, you can deploy in the browser. So there's a simulation of a blockchain in the browser, but there's nothing like that currently. So I'll just write some things here and make some things make sense. So imagine, let's just give it, I'm just going to write the studio code. So function, test function. So text function, and so basically you set something like this. Let's just say set a value. You set a value local. So remember, this is studio code. I know it might not be exactly the same syntax with Cairo syntax, but I just want to make something clear. So let's say you set this as 2, right? In the lifetime of this program, you can't set this again, right? Or at least in the memory cell, because you can reference this, but you can't take X and say you want to replace the value of X. And it's not the same with using lets, because we use lets and we use temp_var. So you can also use this, but they're not the same because these are mostly references, right? So what do I mean? These values are references. They are not the actual value. They are referencing another value. So that's why I use this as a good instance. So this basically just explains that in Cairo, you only have a write once memory, meaning that you can write to the memory but you can't change it. So it's read-only. You can say it's write once, you can call it read-only, but basically you can only write once. Yeah. So then this next point, I said it's also non-deterministic. That is, you, the prover, see the value, set the value in the memory itself. So basically, there are not a lot of programming languages where you are the one that sets memory value. So take, for instance, right, you might have seen a Cairo code where we do something like this. Say, let me just replicate this. Okay, let me make this bigger. Test function 2. You might have seen a Cairo code where we set something like this and say AP equals, let's say, 4. Then we try to increment this. So what this means basically is, right, that this is an allocation pointer. We'll get to that quickly. We'll get to that after this. But basically, I'm trying to explain the fact that you can set these memory values yourself. For instance, now in Python or in like most programming languages, you are not given the ability to say you want this particular value to be in this particular address, right? Those things are left to the programming language itself to do those things for you. But here, you can set it, and you can set it anywhere you want. So you can say that so far you're not, yes, you can actually set it yourself, right? So basically what I'm actually doing here is I'm saying that the value at this particular allocation pointer is 4, right? So basically I'm actually saying that 4 will be set to an allocation pointer in this address. So what this means is that this one's an address, this AP is an address, while this how will I call this now? Forgotten the name of this. Okay, angle bracket. Is it angle bracket? Not angle bracket, but yeah, you know what this I'm talking about. So yeah, basically, I'm setting this myself, right? So basically, it's non-deterministic because I can set it wherever I want, and also I'm altering these memory locations by myself and not leaving it to the program language to actually do it. So in this next line, you see where I said this is used to define the value in the memory address where the address is X. So just the way I'm saying it here, this is an address, right? This is an address. In as much as here, this is like, okay, I know this is a bit counterintuitive, but in as much as I call this an address, this is an allocation pointer, and I'll still explain what that means. But this just see this as an address right now. So basically, I'm saying that this is used to define the value in the memory address where the address is X, right? So for instance, if I set this to 7, so if this was 7, okay, no, let me not use this. Let me use something else because this is kind of unique. So let me just use another value. So yeah, if this is set to 7, then I'm saying that the value in the address 0 is 7, right? So basically I'm setting, they're giving me the ability to actually set values at specific locations, right? So now look at what I said. I said the only values that may be changed during the program executions are registers. The reason why I cleared AP here is because registers are kind of the only part of registers are the parts of Cairo where these values change during the execution time, right? Rather than normal addresses like I said here. So registers can change. That's why I removed AP so I don't create confusion, right? So okay, let me see. All right. So if you have confusion, just drop message in chat. But I think that was a bit unclear. All right. So like I said here, only registers can change during the program execution, right? So when you're running a program, the registers can change because these registers kind of they kind of coordinate the instruction process. So they're in charge of like trying to, okay, so let's just go back a bit, right? If you go to the if you're coming from a computer science background, right, the register basically helps the CPU so that the CPU don't go to the main memory back and forth. right? So basically, there are two types of memory, right? There's the main memory, which is the, like, see your hard drive. Then there's your RAM, right? So because it will be a bit computationally hard, or will I say computationally intensive, more intensive, for the central processing unit to keep going back to the RAM, a register is used, right? So that's just what the register. So basically, during the process of program execution, the register is being used to handle some of these processes. So in Cairo, there are 3 registers that that were mentioned in the documentation. So we have the frame pointers, we have the allocation pointers, and we have the program counters. So here we say the frame pointers point to the frame of the current function. The addresses of all the function arguments and local variables are relative to the value of the register. I will explain this. Then allocation point I talked about, which I said I'll come back to, point to a yet unused address, unused memory cell. What does that mean? So the allocation pointers keep changing, because we can just say, for instance, now I can say that in this function, so let me do something, let me do a function like that again. Text function. So I can say that this allocation pointer should store the value of 3, right? It should store the value of 3. Then I will increment this, right? So basically, I'm saying that this 3 should be stored in this allocation pointer. Then I'll increment it so that the next allocation, the next address should not change this, because if I come here and if I don't add this, which I'm not really sure you can do that, but if I don't add this and come here and set another value, I'm basically altering this value, right? So it only makes sense that I increment this so that at least if I'm trying to reference this tree, instead of me, I'll just do something like this. I'll just do something like this, equals to, say, AP minus 1. I know this is a bit confusing, so just drop a message on the chat if you're not understanding, because I know it's a bit hard to understand. So basically, what I'm saying here is that I set 3 in the allocation pointer, right? Then I increment it. Then I come here and I try to get this value, right? This 3. So knowing fully well that I've already incremented this, the value for 3 wouldn't be this, it would be like AP minus 1, because I've already incremented it here. Then I do the I increment it again, right? So I want to explain frame pointers, then I'll go back to allocation pointer. I just wanted to make a point about how it points to unused memory cells. Then the program counters, which it basically points to the current instruction. So the way this works is that imagine that you had 3 functions to run, right? Imagine you had 3 functions to run. Let me demarcate this. Let me say program counters. So imagine you had 3 functions to run, right? And okay, go ahead, Paul.
Someone just say, can you just check the comments? Said he's lost, right?
I didn't have to see the chats.
Yeah, said that. Just check the chat. Probably just
okay.
Yeah. I just had to like call you back to the.
Okay, he said, okay. Kelvin, can you just like unmute yourself and ask, because I know it's a bit unclear.
Sorry, I didn't get the idea of the memory, because like, okay, I'll use Ethereum as a use case. You have like you can write to storage, and you can write to like memory. Writing to storage is like initial storage is like a code slot, right? And if you write to it, it's quite expensive, right? And you can also like change the values there. So are you saying you can't change the value you write to a particular place in memory? Yeah. And the assignment of these APs goes to 3, and then you're incrementing it. Somehow confusing. I did not like get it.
All right, all right. So when I said, there's difference between memory and storage, right? So the storage
Yes.
here is just the way we do, let's say we want to update balance. So we do balance.read and balance.write. That is storage. That is general storage, right? But when I'm talking about memory, I'm talking about during an instruction, right? In a function, if you're trying to run, now you're working with the memory, you're not working with the storage, the general storage of StarkNet. You understand? So when you're working with the memory in a function or in a set of instructions that are running at a particular point in time, when you're altering values, say in a function, you can't set a value twice. Once you set a value in the memory cell, you've set it. Unless you're referencing the value, then you can re-reference it or like change what you're referencing to. Does that make sense?
Yeah, I guess now. I understand now.
All right, all right. So I don't know, you said, would this assignment be correct? Yes, yes, because basically, okay, no, you're okay, let me check that. I haven't tried that because I think it will be possible because you're basically replacing the value that was there. You're basically, so if I come here and do something like this, I'm basically replacing, but I've not tried it to see if it fails or it throws an error, but I think it will work because you can alter it the way you want it. But basically, once you do something like this, you're you're going back to this particular value that has already been set here. But I've not tried that. I've not tried that to see if it works that way. Yeah. So yeah, so please, if you have any question, just drop it on the chat because I know these topics are kind of, yeah, not easy to grasp. So yeah, I'm talking about program counters. So and also these ideas, these pointers are not unique to Cairo, right? Sorry, these registers are not unique to Cairo, right? So we have registers everywhere, right? You have these 3 kind of registers. The idea, if you have any idea in other programming languages or in computer science in general, you can bring it here. And is something that if it's not exactly, then it will give you, it will help you understand it better, right? So what program counters do is that it stores the address of the currently running instruction. So let's say you want to run you want to run this function. Say let's say test function 2, since we already have test function. Should probably look for a better name for these functions. So and now you're running the code here, right? Every line, for instance, now this is an instruction. So let's say let x be equals to let's say 5, right? This is an instruction, right? Let's come here and say something like let's call another function. Let's say we want to call test function. So basically we are trying to call this function inside this one, right? So what program counters do, which I know this is very theoretical, I don't know how to actually test this for you in Cairo language itself, but how this works is that it's at every point in time, the program counter points to the current instruction, right? So this is an instruction. This function now is an instruction, right? So it has a set of instruction. So it helps to track what is meant to be executed at every point in the program, right? So without this, the CPU would lose track of what exactly it's supposed to be processing, right? So it basically stores, like it tells the CPU, this is what we are currently processing and focus on this, you understand? So this is what the function, the program counters do, sorry. So I want to explain the frame pointers before I go back to allocation pointers, because I think that's the one that will make more sense because something we can practicalize. So now from this definition, right, they say points to the frame of the current function. The addresses of all function arguments and local variables are relative to the value of this register. So basically, let's say we are let's use a stack-based machine, for instance. So what I mean is that let's use a machine that uses stacks, right? So what I mean by stacks is if you're trying, like, if the instructions are coming in, let me see if I have a whiteboard. Can I use a whiteboard here? I think there's a whiteboard. Okay. Oh, let me just remove this. But yeah, basically, what I'm trying to say is, okay, I think there's a whiteboard. Let me just use the whiteboard. Okay, cool. So basically, let's say that we had a stack, right? Let's say this was a stack. This is what I mean when I say stack. So basically, if you want to run instructions, so let me just draw this track. Can you guys see this diagram I'm drawing here?
Yes.
Yes, you
All
can.
right. All right, cool. So now this is what a stack looks like. You understand? So basically, as instructions come in, they are added to the stack, right? So and it follows a pattern called last in first out, which means that if an instruction is here and it depends on another instruction, it will be added on top of this, right? If another one depends on this, to be added on top of it. So when I say last in first out, meaning that the last one that goes into the stack is the first one that will go out. So what I mean is that before this one will run, this one needs to run, and before this one will run, if there was another one on top, let's say another instruction on top. So basically, let's say we're using a stack-based machine, right? Now we have let's say want to do addition, like let's say this was add, right? Wow, this is a bit hard, so but yeah, let's just not use this before. So yeah, let's say that actually wanted to add two values, right? Okay, let me use this. Let me go back to my, I can't use my normal mouse with this phone. Yeah, that's by the way. So basically, what I'm trying to say is, let's say we had a function, right? And we had an instruction, say 2 times brackets 1 times 1. So basically, because the end value will have 2 probably here, they will not have 1 times 1 here, right? So when that 1 times 1 finish processing, it will come back here because this one depends on this to run, right? So basically, I'm just explaining a stack for you. Now let's bring it to the context of what we are talking about, which is frame pointers, right? So now imagine that we want to run a function called add, and it takes 2 arguments, A and B, right? I want to add want to add the value of A and B. Now, and imagine inside that function, we needed to call another function called, let's say another function that does the same addition, but internally. If you have the idea of solidity, you can have internal functions, right? So just imagine that we had that function doing an internal addition, right? So basically, the allocation, remember that the allocation pointer keeps changing, right? It keeps changing. But how do we keep track of all the values when we know that the allocation pointers keep changing? That's where the frame pointer comes in. So let me read the definition again. I think now it will make more sense. Points to the frame of the current function. I mean, we means that it doesn't change when you're running a particular function. so that even if the allocation pointer keeps changing, the frame pointer would not change. So let's say that this contains all the variables and all the instructions needed for a function to run. So basically, then this is where the frame pointer starts. So what it does is that it stores, let me just call this text frame pointer. Yeah, this makes more sense. So frame pointer, right? So basically, now this is where the frame pointer starts, right? So basically, it is storing from this point up till here. So if they were like the arguments of the function, the local variables, it's storing all of them, so that no matter where the allocation pointer goes, it will not lose track of what it is using for the processing. I don't know if this actually makes sense, but just follow me. Right. So basically, the frame pointer helps you to help this operation to keep track so that it doesn't lose track of what's actually working on. That's why they are telling you that the addresses of all the arguments and local variables are relative, because now, because of the frame pointer doesn't change, anytime I want to get a particular value, we cannot get it directly, but we can get it relative to the frame pointer. So imagine we wanted to get this particular value here, right? We'll do frame pointer, the address of frame pointer -4, because it's here, right? So now you're seeing where the word relatives comes in. Because if it was that easy, we would have just said that we should go and look for the address of each of these things, right? But it's inside the function. So basically, it is relative to the frame pointer. So any value you want to get, let's say that the argument A was stored here, and the argument B was stored here. If you want to get A, we do 4 - 3, right? Sorry, FP, frame pointer -3. This is where A is stored, right? We'll do, if you want to get B, we'll do FP, which is frame pointer -2. So that's where the idea of relativity comes in, meaning that the value is dependent on the frame pointer because the frame pointer doesn't change. Assuming the frame pointer was actually something that could change, you will lose track of this value because the allocation pointers keep changing. And something you have to remember is that the reason why frame pointer is important is that functions call other functions inside of themselves. So just know that even if the allocation pointer, like anytime you want to call another function and you don't keep track of what you already have in a particular function, you have messed up everything because you will lose track of the values. So these things are generic, these things are there by design. So it's not like you can make any mistake, but I'm just trying to explain how they are working, right? So up to this extent, does anyone have any question? I don't know if what I said made sense. If you have any question, please drop it in the chat so we can go ahead. Okay, I think let me just save that. Okay. How do I remove this? Okay. All right. So that's that for frame pointers, right? So let me just reiterate what I said. Frame pointers help to store the values variables you're currently working in, all the values necessary, your function argument, your local variables, so that anytime the execution or the program counter changes to start running on that thing, it will not forget that you're running a particular function. And even inside of those sub functions, they still have their own frame pointers because they are functions themselves. So it's not like the frame pointer is only in the main function. When the main function has its own frame pointers, when execution moves to the function that is a sub, meaning that a function that is being run inside the main function, it still changes, right? So that's how it works. Now, one that's very interesting is allocation pointers, and I think there's an exercise there's something I want us to do with allocation pointers that would be really interesting. So let's go allocation pointers. So I want to just explain how it works using an exercise I saw in the documentation. So imagine wanted to create a function that solved this particular operation, x raised to power 16 plus x. So so just like saying x raised to power 16 plus x, right? Want to do this, want to solve this showing it using allocation pointers, right? Rather than doing normal x times x times x times x and stuff like that. So and we are not given a variable, which is where x is 3, right? So how do we write a function that does this using allocation pointers? Because we can easily just do 3 times 3 times 3 times 3 times 3 times 3 and it will give us an answer. But for us to understand this better, I want us to write this with a lower level syntax. I think that's the best way to explain that. So let's say function test function. Please, if you don't get, please just ask a question and I'll do my best to answer. These topics are quite confusing, so if you have any questions, just ask, please. So yeah. Now, first of all, what is the first thing we do? This thing we did here, we come here, we set the value to 3, right? Because they already told us that the value is 3, right? Now we now come here because we've already incremented this. We already incremented this. So if this was 0, this one will be 1 because we already did incrementation here. But on a high level, we're just incrementing it. But don't look at it like just 0 plus 1 or 0 plus 2. Sorry, it's not. Don't look at it like we're just adding 1, 1, 1, 1, 1. Different. It's being added in bytes because it's now in memory. It's being added in bytes. It's not like we're just adding 1, 2, 3 and stuff like that. But that's just by the way. When I'm just saying it's incrementing, I'm saying it from a high level, not that it's just adding 1, 2, 3 in the memory. Those things are added in bytes. Understand? Because they kind of take consideration of how many bytes this particular data type is needed. This particular data type needs to be stored. But okay, to create our
Hey, Gospel, are you still there? Okay, I think he's probably having network issues. Let's just give him like little time to show up. Oh, am I the one having network issues? I don't think so. Yeah, what is this?
sorry.
Yeah, I figured that out. Okay, I think you're back on right now, yeah?
Yes, thank you. So I was talking about monolos. Sorry.
Yeah, I think there's a question in the chat.
Yeah, it was asking to create our smart contract. Are we going to use AP, FP, and PC? So like I was saying, these things are used normally, like they're actually used under the hood, right? They are used, but you don't have to use them because they are high-level syntax that make these things less complex. But if you want to use them, the reason why I want to use them now is because I want to explain allocation pointers. These things are being used under the hood, but you don't have to use them the way so that's just it. Just do your multiplication or addition and stuff like that. So yeah, let's go ahead. Now remember we are trying to solve this equation using allocation pointers. So let's start. First of all, we want to add 3 now. We want to add 3. So we want to multiply 3 the first time because we are multiplying 3. We're meant to do 3 times 3 times 3 up to 16 times, right? So what we do is we do AP minus 1 times AP minus 1. So remember that these things get value. So let me write a comment. So this is basically 3 times 3, right? Which is equal to 9, right? So this is what this first operation does, right? So it is getting, because of, remember, we are trying to get this 3, right? So we would now do, because of we already incremented it here, we'll now do minus 1 to get what was it, what was the value before. So the next one now, since we already have AP, remember AP is now 9. Oh, remember AP is 9 now. So what we do is we do again AP minus 1 times AP minus 1. So now remember, we now have 9 times 9. You understand? It's 1, right? So we now have 9 times 9, right? We're trying to solve this equation using AP. So this will help you understand how it works, right? So what we are doing is that we are saying, give me the value at this particular address, right? Because in as much as this is a register, allocation pointers hold values, right? Even frame pointers hold values. The same thing for program counters, right? So we want to get the address, we want to get the value in this particular location, right? So if we just put this aside, it won't work, right? It's just a value on its own. But once you put this brackets, once you put these brackets, can someone just write the name of this thing? I've forgotten the name of this thing. Let me be using the right word, please. So yeah. So yeah, this is now 81, right? So let me just go again. So AP so we now have AP minus 1, AP times AP minus 1, right? So we have 81 times 81. And someone help me do that calculation quickly. I think that's 461, if I'm not mistaken. I guess. Okay, no, it's bigger than this. It's bigger than this. I think 6. But yeah. So the last one we do AP. So, and this is in documentation. I'll show you where it is. So I just wanted to show you how it works, because you might not understand it if you see it in documentation for the first time. So AP minus 1. Then lastly, we have this value, 6561 times itself. 6561. Okay, someone is speaking. Just go ahead if you want to say something. But yeah, see? Thank you very much. Yeah, I've been missing this since. Thank you very much. Yeah. I'm glad you guys are following. So yeah, yeah, this is meant to be here. Unless these things I've been doing would not even work, because these things are not incrementing. Thank you very much, Manolo. So yeah, we need to keep incrementing this. We need to keep incrementing this. Yeah. And Kelvin, thank you for the value. I wasn't going to go at the calculation myself, because, but yeah, now this is the value of, like, if you go and try 3 raised to power 16, you find that this is the end value. Now, this is how we did it using allocation pointers, right? Then lastly, we'll now do this AP equals this value, AP minus 1, which is this, plus, now see where the confusion might come in, AP minus 5. Now, hear me out. See, this is why I'm using 5. If I want to get this value, I did minus 1, right? If I want to get this value, minus 2, right? This value, minus 3, this value, minus 4. Then this value here, minus 5, because this is where we set it as 3, right? Because if you do minus 4 here, you'll be getting, let's say here, this 9. If you did it here, you'll be getting 81. If you did it here, so we had to do minus 5. But now in the documentation, you will see that they said that this is risky because you might start asking yourself, why is it minus 4? Is it minus 6? Is it minus 7? So this thing might be confusing. So what they did was that they first did this. They said L, let X be equals to AP. Then they now did X equals to 3. Now, you know, X is distinct, so you can now easily come here and do X. So let me see if I can find where they said it on documentation, so you can go and check it out later. Yes, so this is it. Let me send this to the chat so you guys can check it out later. Okay, let me drop it in the chat. So yeah, so this is a value. So this will be our end value, right? So yeah, so our answer is this. Okay, somebody sending on that value, but just know that I can't really start confirming now the value which is more correct. But yeah, any of them, I think. But basically, if you wanted to do 3 raised to power 16, this is how you're going to be using allocation pointers. This is not about trying to understand what 3 raised to power 16 is, but basically to understand what allocation pointers are. So just look at it using that mental model per se. Now, like I said, all these things sound very theoretical, but I believe if you want to understand it better, you have to, like, I think you see these things with time, because I can't say it might be a bit confusing to start looking for Cairo code that will exactly do these things, like say that will start explaining program pointers. Just like in documentation, these things are not really clear. But I think with time, the more you write Cairo, you see this thing come to light. That's why this thing is kind of things that are in depth, and things that are not just in the surface level. So yeah, I think that's that on registers. Please, if you have any questions, drop it in the chat. I'll do my best to answer. Thank you. So yeah, let's go to the next one, which is revoked references. So this is a very confusing concept, right? Because it's not even intuitive. It's not intuitive, especially if you're coming from other programming languages, but it makes sense. It makes sense if you understand how it works. So basically, I said, if this is from the documentation, also, if there is a call to another function between the definition of a reference that depends on AP and its usage. So this is allocation pointer. So this is allocation pointer. Anyway, CAP, just allocation pointer. So yeah, depends on allocation pointer and its usage. The reference may be revoked since the compiler may not be able to compute the change of AP, as one may jump to that is by the way. So basically, what am I trying to say? You know, before I said that the frame pointer stores the values that are currently being used and it cannot be changed. But the allocation pointer can be changed, right? It changes, right? You're setting new values, right? That's why we are using it we are getting other values in relation to the current allocation pointer. You understand? So we are not doing like when we're doing this calculation here, we are doing -1, -1, -1, -1, right? It's relative to the current one because it's currently changing. And if you now move to the context of another function, you find out that you lose all these values, right? If you were like you lose all these values. That's why frame pointers are very, very important. But that's just by the way. So what it's actually saying is that, for instance, if I was running two functions, right? And let's say, let me explain this. So basically, this is what I'm talking about. This is how I'll still go. I have code for this, but let me just do this, and I'll take it to the code. So let me do test. Just test reference. This is the code for this. So what they're actually saying is that if I do this L, this is from a high level. This might not give you that error, but I'll run a code now that will give you that particular error because it's an error that needs to be fixed, unless your program won't run. So that's what it's just tells you that the reference has been revoked. But basically, imagine that like I said, this might not throw that error, but this is what they're trying to say. Imagine that you set this value as 5, right? And you run a function here, right? And you run a function, say test reference 2, right? And now you now want to use this X in a third function here. Test function, test reference, let's say 3, right? You don't want to use it here. Like I said, this might not throw the error, but what they're actually saying is that because we have set this value here, right? This might, I don't think this would throw, but from a high level, this might throw because they are assuming that this particular function might have changed this value. I don't know if that makes sense, but I'll still show you what that means. So basically, they're trying to say that the reference may be revoked. Since the compiler may not be able to compute the change of AP, as one may jump to the label from another place in the program or call function that might change AP in an unknown way, right? So imagine that this particular reference, this particular function change this thing in a particular way. That's what they're trying to tell you, right? So this in fact, this will not throw, but just trying to explain to you using functions, right? So basically, they are trying to tell you that this function might change this, right? So using it here, as when it reaches here, I tell you that it's already been revoked because now the compiler is not able to compute what is the value right now because it has already been changed. That's already been changed. So let me stop sharing my browser and share my my code. So let me share this code. Okay, this is it. I'll share this repo at the end of the class. I'll just add it to my slide. Okay, what's happening? I mean, I want to share my screen. Yeah, so I hope you guys can see my screen. Okay, you said yes, thank you. So yeah, if I try to run this function, if I try to run this particular program, this revoke reference, let me just try to build. I'm trying to build all my program, but this will cause an error. Okay, no, let me, I think I ignored it. Okay, let me uncomment it. So basically, see what this is telling us, right? I don't know. Let me make this bigger, right? So look at what it's telling us. It's saying reference h hash ptr was revoked. You understand that they're telling that this thing was revoked. So this particular value was revoked. So let's see why. Let's explain why. Let's see why it was revoked. So here, this value was set here, right? This value was set here. Now, last week, Darlington talked about butenes, right? He talked about butenes. So this is a butene, right? So this hash PTR is a butene. And it helps us to perform operations like hashing for you to get the pedestrian hash, right? I think that, yeah, so it helps us to compute pedestrian hashes, right? Now, when we use it here, right? When we use it here and we run this function, now we came here to use it. But when it reaches this point, the program is already telling you that, sorry, we assume, because it's conditional, because there's even a way, there are ways to trick your program into not throwing this error, but it might still have cases like that, right? So they're telling you that this was revoked because they feel like they don't know, like they are not sure. Like, how will I put it? It's not like the fact that you can bypass this shows that the program just kind of predict that this can be changed during the execution time. So it doesn't even want you to do it. But it's not like it can, because there's a way to write, especially when using if statements. You can say if this, and to just bypass this error. Or you can bypass this error, but your program might still fail, even if the program doesn't, even if it doesn't catch it, kind of. So yeah, so what is telling you that this was, why trying to retrieve this was revoked, right? So this was revoked because they are assuming that it was used here and it might have been revoked, right? So it was used here and this function was called. So they are saying that if you want to use it here again, they are saying that it might have been revoked, right? So basically, how do we solve this? So we solve this by adding this, which is we are redeclaring it. We are telling the program that I want to use it again. So we are redeclaring it. We already have it here and it was used here, right? So we're telling the program that I want to declare it again and use it here. You understand? Because the way he talked about implicit arguments. So this hash function automatically takes this in, because it will just tell you that this uses, this function is using this hash ptr, right? So that is how it's currently working. So, but for this lookout to work, you need to put this, right? So that's why we'll have to uncomment this out. So if we try this again, yeah, this works, right? So basically, the way we solve this problem was just by adding lookout. So we redeclared it, telling it that, okay, in as much as you feel like this might have been changed here, we are redeclaring it again to tell you that we are using another instance. I guess that makes sense. But you can drop your question if that's not clear. And you might see this error in different, like random scenarios. So this is just my own example of trying to explain it. You can have scenarios whereby you're even dealing with you're not even dealing with implicit, you're dealing with something else, right? I've been writing, at the one time I was writing Cairo, I was dealing with trying to calculate something and just telling me to work error and stuff like that. So you can see it in order, but one way to solve this is by bringing in this, right? So these values local to this function. So the way to solve this is if you just add this local and set these values in local, most times it will solve your problem. Why I'm writing Cairo. Sorry. So yeah, that's that on revoked references. Please ask your question before I go ahead. So let me go back and share the browser screen again. Let me go back and share the browser screen. Yeah. So next we have recursions, right? So if you've been coding for a while, the idea of recursions, you might have heard it. You might not understand it, but you must have heard it, because recursion is that topic that you always hear about, but it's not really easy to understand. But yeah, Cairo doesn't have loops, right? You must have, because if you know, control structures are one of the first things you talk about in programming. So by this time, if you've not heard it, then you know that there's something wrong, or you've probably seen it in documentation. So there are no loops in Cairo 1.0, which is coming out soon. We should have loops.
Okay, I think we lost him again, but then let's just give him a few minutes to join back, okay? Let's say a minute to join back. Okay, welcome back, man. Let me make sure. Okay, I think you're sick, host.
Yeah, sorry. Yeah, just let me continue. You can hear me, right?
Yeah.
All right, cool. So, like I was saying, Cairo doesn't have loops, right? And from what I read in Cairo 1.0, there will be loops. There will be like for loops and while loops, but they are not changing how it works under the hood, which is still recursion, because of the memory is still immutable. So Cairo doesn't have loops mainly because the memory is immutable, right? So recursion is basically when a function repeatedly calls itself. So, you know, what loops, like what you would be able to achieve using loops, you'll be able to achieve using recursion. That's why we're even talking about recursion, because in programming, there will always be cases whereby you need to do things that require going around a particular, like going around the circle per se. So basically, in Cairo, if you want to achieve things that require us to use loops, we need to use recursion, right? So, and now, so basically, I said here, a recursive function should have a terminating condition so as to avoid an infinite recursion. So what does that mean? So imagine you just keep doing the recursion, and you don't have a condition that says that if it reaches this particular point, it should stop. You understand? So if you don't have that kind of condition, your program just keep running, and if it's on the blockchain, you probably run out of gas. Or in fact, I'm not even sure Protostar will allow you to compile if you have such a command, right? So as you see in my code, every recursion should have a terminating condition. Right? Yeah, it makes sense. So it doesn't go into an infinite loop or an infinite recursion. So let me share my VS Code again. I have two examples of recursion. But yeah, let me share the screen again. Yeah, so let me show this and make this small. So recursions, right? So I think if you the most popular example of recursion is the Fibonacci sequence, which you'd see most times when you want to talk about recursion, right? So let me explain this code, right? So here are two terminating conditions which would definitely be reached, right? So it doesn't run forever. So basically, in fact, if this termination condition doesn't hold, like this terminating conditions kind of says like it is what's telling the program that this is where it should stop. Right. So if there are no terminating condition, it's a problem. So so we are saying like here's the formula for Fibonacci sequences. So okay, let me explain what Fibonacci sequences are. So basically, if we had this is a Fibonacci sequence. Let's say we start from 0. It's always starting from 0, 1. Then if you want to get the value, next value, you have to add in the 2 first values. So now we have 1. Then you add in this 2 value, we have 2. So we add in this 2. We have 3. We add in this 2. We have 5. This we have 8. We have 13, and so on and so forth, right? So this is the Fibonacci sequence. But now, at this point, you must have thought about what if we want to find the 1000th number, which you cannot start doing this thing now. It just doesn't make any sense, right? So there's a formula for Fibonacci sequences, which is basically if the number, like for instance now, if you want to add the value passing here, is if you want to find the 1000 value, you put in 1000 here, right? So that's what n represents. So see the formula here. If n is 0, you return 0. If it's 1, you return 1, right? In fact, some people start Fibonacci sequences from 1, 1, because this 0. Let's just move that 0. So this is what would actually make this formula hold. So if we are looking for the 0th value, because this is a 0 index, right? Just like array 0, 1, 2, 3, and so on, right? So this is 0. This is if you're looking for the 0th value, you return 0. If you're looking for the first value, you return 1, right? So now if either of these two things doesn't hold, then we now do this, which is n minus 1 plus n minus 2, right? It keeps doing that, keeps doing that, keeps doing that, keeps doing that until any of these conditions hold. Then it returns the n value, right? In fact, recursion in itself is confusing, even without even bringing this into the syntax of Cairo. So it's confusing in itself, but just know that the reason why we are using this here is because we want to be able to achieve, because it's actually easier to achieve this with loops, but that actually comes with a performance problem, which is if you want to, like, even if you wanted to create a Fibonacci program that would run like for 1000 values, you'll find out that your program becomes slow as
Tony's.
Oh, damn. I don't know what is wrong, but he'll be back soon again. Yeah, I think his network is like a bit messy today, but then he'll be back with us very soon. Let me just hit him up. Okay, so he's back again. I don't know. Gospel, what's up?
Yeah, my network is really bad. Sorry.
Yeah.
My network was really bad.
I guess you were explaining something initially.
Yeah, sorry for that. Let me just go ahead. Yeah, I was talking about this program, which is basically the problem is finding a number in an array, which is finding, like, want to see if a particular number is in an array. Say we have an array containing 1 to 5, right? So we want to say, does this array contain 1? Does this array contain 2? Right? So yeah, so how do we achieve this? So first of all, we say if the length is 0, return 0. So this means that, okay, let me explain this values first. So this is the number we're looking for, which is the needle. Then this is the length of the array, which is very important for this recursion, because without the length of the array, you can't really track the array, right? Then this, which is very, very important, is a pointer to the first value of the array. Remember that. You don't pass in the full array into the function. You pass in a pointer, right? So here, what I'm passing in here is the first value, right? So the way Cairo does is that, let's say we had, let me do this here. Let's say we had 1, 2, 3, 1, 2, 3, right? So what is going to be passed here is the address of this one. Is the address of this one, right? Because you're not actually passing in the full array. Understand? Cairo doesn't do it that way. Or languages that use pointers, they don't pass in, they use pointers. So we are basically pointing to this first value. Because this is something that's going to really confuse you. Because when I was learning this, I was always asking, why are we decrementing the length and incrementing the pointer, like the address, understand? So always remember this, right? So now back to what I was saying, if the length is 0, we want to return 0, because that means the array is the array is empty, right? An array of length 0 is an empty array, right? Now we are not saying that if this particular value is the number, then we should return 1, which is basically Cairo's way of saying true or false. 1 and 0, and so on, 0 and 1, right? So basically, now, in as much as this is a pointer to the first value, Cairo still sees it as an array. So you can do this. This is a bit counterintuitive based on what I just said, but just see it like that, right? This is a pointer to an array. But if you try to get the 0th value of an array, Cairo sees it as like you're trying to get the first value in an array, right? So this basically checks, is the first value equals to the number we are looking for. And mind you, it's going to be the only value, because it's always passing in only one value, which is the current value, right? So now here's where it's very interesting. Now, if these two conditions doesn't hold, we come here, we add the number again, we reduce the length by 1, because as we keep going, we want to make the array smaller. We want to make the array smaller by removing the first value, right? So we want to make the array smaller by, so it's just like we are pushing it. You understand? We are actually pushing it so that at a particular point it will hit 0. You understand? So it keeps going, it keeps checking. So if you don't do this, if you don't keep decrementing the length, you find out that this turns to an infinite recursion, because you just keep going and you would never. So basically, we are saying we want to reduce the length. So now, if this was this, it will now change to this, right? It will now change to this value. Okay, this length is 2. It will change to 1. Then, okay, this particular pointer was pointing to this bar. It was pointing to this first one, right? Now, when we do this, it will now start pointing to this one, because we are now passing in the pointer of the next value. And remind you, we just decremented this by 1. So now it will now be looking at this number as this, right? It's not looking at the array this way. All right, so we just decremented it, right? So that if you check the first one is not available, no problem. It will reduce the length and then increase like changes to this one, right? So because this is what it will look like. Or in fact, the way you actually meant to say it is that it might still be this way, but basically this pointer, which is what we are working with, is now pointing to this number, and so on and so forth, right? So at a particular point, it will now be 0, because if we check this one, is not available, no problem. Okay, do you want to ask a question? Okay, so basically, this array still remains the same, but the pointer is changing. You understand? The pointer is changing, and this now, and so on, and it keeps going through until it finds the needle, which is the number we're looking for, or it doesn't, right? So that is that on this particular example, right? So lastly, this is not on the slide. This one I'm talking about is not on the slide because I didn't see the name on the slide. So I want to talk about tests in Cairo, right?
Hey man, what's up?
Yeah, I'm back. That's
I don't know. Mine also like cut off as well. I don't know if it's yeah, but then
I
just
think
right.
it's yeah. I'm almost rounding up, guys. I'm sorry for the network issue. I'm almost rounding up. So let me just talk quickly through the program, the test, which is I'll do that quickly. Almost rounding up. So now basically, this is the test program that comes with Protostar. So this is a storage variable, like we've been taught previously. This stores the balance, it stores a failed value. Then this is a function that increments that particular balance value, right? So it basically just gets the current value and increments it by the amount that you want to increment it by. Then this gets a balance. Then this is a constructor that basically sets the balance to 0 at when the program is created. Now, this is the test, right? This is the test of this program, right? So basically, first of all, what is the goal of a test? The goal of a test is to simulate all possible scenarios that you want your program to actually have, like all the programs. Sorry, someone asked. Clarification on what exactly? Okay, I'll get back to that. So your test is supposed to simulate all possible scenarios based on
Oh damn. Hey, Gospel, are you still there? Okay, I think his network is off again.
can you hear me now?
Yeah. Thank God you're back.
All right, it's really okay. Getting the entire okay. Okay, I'll get to that now, please. I just want to round up this. So in case this network keeps doing this. But yeah, I'll get back to that. So basically, we're trying to test all possible scenarios. So let's go through this first test, right? So basically, first of all, want to assert that the first that is initially 0, right? Because when we first create this, it should be 0, right? So we want to assert that is 0, right? Then at the time when we increment this balance, we now want to assert that it is 42, right? So the way assert works is if one of these values are not set, it just takes either of them to either side. So basically, if this was not set, you're going to set it to 42, and the other way around. If this was a variable and this was 42, it's going to set it to 42 on the other side. But if two of them contain values, it now works as we know assert to work, like basically just compares and throws an error, right? So yeah, so in this particular case, it will ask whether these two values are the same, then it throws an error, right? If they're not the same, right? So this basically is doing the testing, right? Then here, we want to test for negative values, right? So want to read this value, now want to pass in a negative value.
Hey man, I think we lost you again. Probably you can just adjust a bit where you are right now. Okay. Okay, I'm trying to get Gospel back on the call. Okay.
Yeah, so
yeah, I think you're having a hard time today with the network.
Yeah, a lot of issues. Sorry. So I think I'm done. So basically, like I said, the expect reverts, it's a cheat code, and there are more cheat codes. Let me send you the link to Protostar documentation. There are a lot of cheat code that are available. I think also on the doc that Darlington, like on the resources in the curriculum, you will find the documentation there, but let me just send that for you guys to go through it. But yeah, I'm sorry for the network issue. It's just so much. Sorry. So yeah, let me send you this. And KP, I would actually let me see if I can. Okay, said asked about returning the entire elements in the array. Okay, first off, an array is not a data type in Cairo. So like an array, like the only data types are felt and structs. So I've not tried returning a full array, but I don't think there's a way to return a full array. Rather, you kind of set a location for the array, then you keep incrementing it, right? Then when you want to return the array, you return the pointer, because you can't return the full array. I've not tried that before. Sorry, I've not tried that before. So if you try that out, or I would actually go and try that out and see what it works, but I've never done that before. So yeah. Does anyone have any other question before I round up? Can you guys hear me?
Yeah.
Yes, yes.
Yes.
All right, cool, cool. All right.
Yeah.
Yeah.
Yeah. If thanks for the class, man. I mean, even though the network like was messing up a bit, but then it was still not so bad like that. And thanks for the class, Gospel. And yeah, for the recording of this class will be available tomorrow morning. Right. So I'm going to like put it together and send it to the group tomorrow morning. And if you have any questions, like further questions, you can always ask in the group. As we have always seen, like people are always like helpful to always helpful in the group, like want to answer questions and all. So you can always ask in the group. And yeah, next week we'll probably have the StarkNet team in. Okay. KP, do you still have any question? Do you have any question like for today's class? Yeah, Gospel, I mean, Kefi is asking why today's class is short.
Is it short? We actually started by now, and it's almost 7.
Yeah, I get that. I mean, you know, other classes like maybe it's like a 2 hours sometimes and all, but then I get that. I get that. Okay, so yeah, no issues though. If you have questions, okay, Manuel said it's okay but for him. So if you have any question, you can always like ask in the group, okay? Yeah, so thanks for the section today, Gospel. Next week we'll meet the same time. So I'm still trying to like get stuck with him to like join us and discuss one or two stuffs. They have been busy, like they have a lot of events to attend, so I mean I get that. So by next week we'll see what we can pull up with that. Okay, well, thank you all for joining today's class as well, and also for the assessment we said I will talk about today. Then again, is it the one Bravos talked about, KP? Okay, yeah, I saw that as well. I mean, I saw that as well, but then I've not like read through the. I mean, it's actually a very good this thing idea for like to have such should I call it like rival with between wallets in StarkNet, because it will help them improve. I mean, the same way we have seen stocks can come up and also like with. Okay, yeah, okay, so we'll meet in the next class. Okay, so see you same time next week. Bye-bye. Yeah. Yeah, good night everyone.